Alright, so what we're going to be talking about in this video is transformations of the sine and cosine functions. Um, and so I just want to briefly go back to college algebra and recall how we transformed functions in those classes. So if you had some function, and let's just sketch out like a, yeah, let's just say it looks like that. Some weirdo function with x and y values. We can transform this function by shifting it up and down, shifting it forward and back, and stretching it this way or shrinking it this way, stretching it and shrinking it this way. So let's start with some basics then. If I shift forward by, let's say, h, I do that by subtracting h from every value. And the way we want to think about this is, let's say h were 3 or something. If I take each value and x value and I subtract 3 from it, then everything kind of is delayed by 3 units, right? If I things that used to happen when x is 0 would now happen when x is 3. Things that used to happen when x was 5 now has to wait until x is 8. So by subtracting h, what you're doing is you're shifting out by h, right? And so that action is just shifting everything to the right by h units. And if h were negative, then you'd be shifting things to the left, because now things happen sooner than when they would have happened before. Similarly, if I just added k to the output, right? So here, this is an adjustment on x, right? This is an adjustment on the input, and so I'm shifting the input forward and back. Now I've evaluated the function and I'm adjusting the output. So now the outputs change. So in this case, my output goes up by k. Now it's going k up or down, right? If I subtracted some value, then I would be going down. If I added some value, I'd be going up. All right. Now let me switch colors just so that like we can keep track of everything. Let's say y is equal to f of ax, right? Then what's happening now is that things, like if a were 2, then everything happens twice as fast. Things that used to happen at 1 now happen at a half. Things that used to happen at 4 happen at 2. Things that used to happen at 8 happen at 4. So what will happen now is everything gets kind of smushed in by half, right? Because everything's kind of compressed and sped up. On the other hand, if a were less than 1, let's say a were 1/5, then things that used to happen at 1 would happen at 5. Things that used to happen at 5 would happen at 25, and so on, right? Things would get stretched out. So if a were less than 1, that would result in a stretching. And finally, if we were talking about, let's say, adjusting the outputs now instead of the inputs, then instead of my time frame being stretched or shrunk, my outputs are stretched or shrunk. So now, if b were greater than 1, then everything would be pulled up. Everything would double, say, if b were 2. And if b were a half, then everything would scrunch down by a half. Alright, so let's kind of see this play out in practice. So here I have a function cosine of t, and here I have a transformed version of cosine of t where I have a shift of B, a left-right shift of B, an up-down shift of C, a input shift of K, and an output shift of A. And so A and K are set to 1, B and C are set to 0 right now. And so that gives us 1 times cosine of 1x, which is cosine of, or cosine of t, which is cosine of t. So we'll start by adjusting the left and right shifts. Right, again, as I move B up, it pushes everything back. As I move B to the left, it pushes everything forward, right? But so what we'll notice here, though, as I do this, is that if I do this, if I push everything forward by 1 point or back by 1.2, say, the output certainly changed, but my highs are still at 1, my lows are still at -1, right? The length of my periods is still the same because they're just shifting back and forth. My midline's still at 0. All of those properties stay the same, right? And so that would change, that would be the same no matter what I did to B. So let's take a look at shifting up and down by C then. Alright. If I shift up and down by C, well, what changes now, or what doesn't change now, is the period, right? I still have 2 pi lengths periods going forward. But now my midline has shifted, right? And this makes sense if I bump everything up by, let's say, 3. Let me move it all the way up to exactly 3. Then my highs should go up by 3. My lows should go up by 3, right? Everything shifts up by 3. But what we should note, though, is that my midline doesn't change, right? Or not my midline, my amplitude doesn't change. My midline goes up by 3, but the amplitude, the distance from the highs and lows from the midline, that's still 1. So why don't we summarize that in, just keep track. So let's see what we've done so far. So horizontal shift by, let's see what we're calling this. We're doing horizontal shift by yeah, let's do this. Let's write everything. So if we do a horizontal shift by B, we get no change in properties, right? If we do vertical shift by C, we get midline is y equals C. But that's the only change, right? The amplitude's still 1. The period is still 2 pi. And the other thing that changes also is the range, right? The domain is still all real numbers, but the range, now instead of going from -1 to 1, in this case, the blue dotted line here is going from 2 to 4. In general, the range is going to be the midline minus 1, the midline plus 1, right? So let's bring you back down to 0. And now let's take a look at stretching or shrinking horizontally. So let's say I'm going to shrink in horizontally by a factor of 2. And let's take a look at what happens there. Now everything's scrunched in, right, by a factor of 2. So everything's happening twice as fast. So now we're looking at, let's see, horizontal. Let's say stretch by k. And so what we see here is that our values still range between 1 and -1, right? They come in, or they still range between -1. Our midline is still 0, right? Our amplitude is still 1 because we haven't stretched this way at all. But things are happening twice as fast now, right? And so what we have is a change in our period. The period is now going to be 2 pi over k, right? So in this case, it used to be that every 2 pi cycles we'd make a revolution, and now it's happening every pi, right? Every pi we're making a revolution. And this works also if our k is less than 1. If we're 1/2, then you're dividing by 1/2, so stretching everything out by 2, and now everything's taking twice as long to happen compared to what it used to be. Alright, let's set this back to 1. And now let's talk about a vertical stretch. By A. So if I'm doing a vertical stretch by A, we can see that that stretches everything out by 2. So it doesn't change your midline, it doesn't change your period, right? Because everything's still taking 2 pi cycles. But what's certainly changed now is my amplitude, right? I used to go from -1 to 1, and I've doubled everything, so now I'm going from -2 to 2. So if I do that, then the amplitude is A equals A, and this is why we're using A here as our measure, because that A is the amplitude of this particular function. Alright, so those are all of the sort of changes of that you can make individually. Now the a natural question becomes, what sort of what happens if we start to combine these different sort of transformations? So let's say we want to transform cosine so that, let's say the midline is y equals 3. The amplitude is A equals 2. Let's say the period we also want to be 2. And what's another thing? We want cosine. We'll just leave it at that. I think that's a good problem to. Yeah. So let's see what transformations are necessary in order to achieve a transformation of cosine that would have these properties. So first things first, when it comes to the midline, there was only one transformation that changed the midline, right? Stretching things this way doesn't change the center, and shifting left and right or stretching left and right doesn't change the center line either. Only shifting up or down could change that, right? So we need that, we need shift up by 2 units, right? And then for an amplitude of 2, right, what we found before is that the amplitude is how far up and down you stretch, right? So for your amplitude to be 2, we need that A is 2, right? The A factor there is your amplitude. So that has to be 2 as well. Sorry, this should be a 3. I don't know why I said 2. Right, we're moving up by 3. And finally, the final piece of this is that our period is 2. So in order to see that the period is 2, we notice that 2 is the period, which is also 2 pi, what do we call this, over k, right? Which means that k is 2 pi over 2, which is just pi. So then the transformation that achieves this is cosine. So k has to be pi. The whole thing needs to be stretched by 2, and the whole thing needs to be shifted up by 3. So y equals 2 cosine pi t plus 3. Let's just turn that off for a second. Let's see here. That's a transformation of cosine. The period is 2, right? It reaches its peak every 2 units. Its midline, it goes between 1 and 5 as its range, right? And so the midline is halfway between that, which is 2, right? And if I draw the line y equals 2, or y equals, 3, rather. Y equals 3 is halfway between 1 and 5. That's right in the middle. So this distance is 2, and this distance is 2, so our amplitude is 2, right? So all of the things we're looking for, check out. And I can make that more explicit if I just said, okay, I want to stretch by 2, I want to go up by 3, and I want to speed things up by a factor of pi, then that is the same function I described, right? And so b is still 0, so I just get pi times t on the inside of the argument, and then times 2 plus 3 on the outside of the argument, which is what we found here, right? And then what you want to know is that if I go from cosine, I was just using that as example, to sine, nothing's different, right? All those things didn't depend on what sine and whether or not I was using sine and cosine, because they all share the same attributes. So, these parameters would still create a variation of sine that was an upward shift by 3, stretched by 2, shrinking it by pi. Alright. Thank you. If you have any questions or comments about this, please email me or post in the discussion board, and I will see you in the next video.